Here is an example of a word problem using the angle of elevation. We are going to go through this problem piece by piece and deconstruct it, and we're going to kind of break it down to where we will be able to solve it almost exactly the way we would if we were just given a right triangle with a missing side. The first thing that we need to do is read the problem and draw a picture. So the problem that we're going to be working with is a kite is flying 70 feet above the ground and is attached to a string tied to a stake on the ground. The angle of elevation formed by the string and the ground is 40 degrees. Find the length of the string to the nearest foot. Again, draw a picture. Draw a picture. So here I underlined a lot of the important information that kind of helped me see what the picture should look like. So I have a kite is flying. Well, if a kite is flying, it's got to be in the air. So I know my kite is going to be at this point on the right triangle. And I know that my ground has to be the horizontal. And then here, I know that my string is going to be the hypotenuse. So now I take this information, and I'm going to take this picture and I'm going to label it. So the first statement that I underlined was 70 feet above the ground. When I think of above the ground, we need to think height. We need to think height. So right here is letting me know how high that kite is. The angle of elevation formed by the string and the ground is 40 degrees. This is an angle made by looking up. So if I'm down here by my stake and I'm looking up at my kite, this is my horizontal, this is my new line of sight, so I'm creating an angle of elevation right down here. And then finally I was given to find the length of the string. Well, my string is my hypotenuse, so that's what I'm looking for, and I marked it X. So the first thing I did was looked at the information that I had and figured out where it went, and then I looked for the information that I needed and went ahead and marked it, and I named it X. Now I need to ask myself some questions. Are we looking for a side or are we looking for an angle? I'm looking for a side. The hypotenuse is a side. What is our reference angle? Our reference angle is the angle that we're going to use to associate a trigonometric ratio. We want to be able to use either sine, cosine, or tangent, but I need to have an angle in order to do that. And that's what our reference angle is going to be, this 40-degree angle right down here. So if this is my reference angle and I have 70 feet and a hypotenuse, what is 70 feet? 70 feet looks like the opposite to me. And then here we have the hypotenuse, so opposite and hypotenuse smells like sine to me. So if I was going to set up an equation, my equation would look like sine of 40 degrees is equal to 70 divided by x, because 70 is my opposite and x is my hypotenuse. So now I just need to solve for x. So here we can essentially cross multiply, and we can multiply x times the sine of 40 is equal to 70. Well, I divide both sides by sine of 40, and I get x is equal to 70 divided by sine of 40 degrees. And that will give me 108.9 or 109 feet. Again, you can just plug that in your calculator. As you can see, once we drew the picture, a lot of our information just fell into place, and this right here is exactly the same as all of the exercises that we did in class on Monday.